Hey everyone, my name is Jeremy McPeak for NetTuts, and welcome to a new short series entitled Writing a JavaScript Library. Now, I imagine the first question popping into your head is why? Because we have an abundance of JavaScript libraries already available to us. Well, there's two reasons. One, it's a good learning experience. We can write our own library, we can refine it, and we can use it in our own projects. So it can be a work in progress as we go along. As we learn new things, then we can apply it to our library, and even from writing our own code, we can learn some things about JavaScript. The second reason is because there's no other person than ourselves to determine what our actual needs are. And while every JavaScript library that's available has every feature under the sun, there are some times when we don't need certain features. So we can write a library that is tailored to our specific needs. And the library that we are going to write within this series is kind of based upon my own. There are some extremely oversimplifications just for tutorial purposes, but I am primarily a component author. If I'm writing JavaScript, it's usually because I need some type of UI component. So this is going to be geared more for component authoring. But even still, we are going to go over some techniques that you can use in writing your own JavaScript library, as well as just plain cross-browser JavaScript. The purpose of a library is to provide a unified API for cross-browser JavaScript. So there are some features that we need to absolutely have in order to meet that requirement. First and foremost, we need to have an event API. We need to be able to set and remove event handlers in a cross-browser way, so we are going to discuss that today. In the second part, we are going to look at how we can manipulate DOM objects, that is with style and creating elements, adding them to the page. We'll also discuss Ajax, and that is another cross-browser issue. In the third part, we are going to discuss how we can add some custom events, because this is going to be a component-based library. So it would be helpful to have some type of custom events. We'll also have some utilities for JavaScript inheritance and things like that. So we are going to get started with events today. And in order to do that, we just need to get started with our library. We need to decide how we want to use our library. I like working with objects. JavaScript is an object-oriented programming language, and I'm an object-oriented programmer. Now, you could say that JavaScript is a functional language, and that is true, but everything within JavaScript is an object, so we are going to work with objects. And the object that we are going to create for our library is going to be created with a constructor function, and it's going to wrap around an HTML element. This will allow us to inherit from this base object later on so that we could write components. But that's later down the road, but we want to lay down the groundwork for that now. So this function is going to be called xObject. It's going to accept a value called obj or object, and this can be either a string, which will contain the value of an ID attribute, or it will be an HTML DOM object. Now, you may notice that this starts with a lowercase x. The traditional convention of constructor functions is to have a capital letter as the first letter. Well, this is a constructor function, but it's also going to be the entry point for some static helper methods. So if we don't want to create an object, but we still want to use the library for some utilities, then this is going to be our entry point to it. So yes, it's a constructor function, but it's also going to be used as an object. So I'm opting to put the lowercase letter here instead of the uppercase. Now, there are two properties that we need. Since this is going to wrap around an HTML element, we need a property to point to that element, and then we will have a quote-unquote private property that will be shorthand for accessing the style property of that element. So since object here can be two types of data, we need to first check to see if it's a string. So type of object equals string. Then we are going to assume that this is an ID attribute or a value of an ID attribute. So we're going to call our element property just EL, and we will call document.getElementById, and we'll pass object. Now we also need to make sure that object could be an HTML element, and we could else if type of object, we could just do this. If it's an object, then assign L object. But this isn't very safe because we could just pass any object to the constructor and this would be true. So we might want to do something a little bit different. We want to make sure that it is an object, but we also want to see if there's some other type of property. I'm just going to choose inner HTML. And if that is not undefined, then we can assume that our argument here is going to be an HTML DOM object. So we are going to assign that to our L property. And then if any other type of data is passed, we want to throw an error. So let's throw a new error. And let's say that argument is of wrong type. And now our second property is going to be underscore CSS. This is quote unquote private. You know, the convention is to prepend an underscore for quote unquote private properties. It's not private, you can still access it, but at least it's following the convention there. And this is just going to point to style. So in the second part, whenever we start working with the manipulation of an element style, then we will use this property. So in order to create an object of this type, we just need to call the constructor function with the new operator. Equals new xObject, and then we'll just type in some random text. Now, if we omitted the new operator, then of course this is not going to work. We are not creating an object here. We are actually creating an L property and an underscore CSS property on the window object, because the new operator tells JavaScript that we want to create a new object of this type. Now, sometimes we do forget new, and really it's a lot easier if we just omit new, because that's less typing on our part, and we can just type our variable equals xObject and then pass whatever. So we can actually force the creation of this particular type of object, and we do that by checking this variable if it's equal to window. Because if we do omit the new operator, then this is going to point to window, and so all we need to do then is return a new xObject. Pass in the argument. So now we are forcing new, so we can call it just like this, and we are creating an xObject object. And if I comment, if we comment this out, IntelliSense should, we're not seeing any other types of properties here, our L property or our underscore CSS. But if we uncomment those, then we are going to see these properties here. So we have essentially forced new, so we can call this constructor function however we want to, either omitting new or with new, and we will still get an object. We have a good start for our library, so let's see how we can add an event API to our library. Now, events are very important because we write event-driven code, so this is going to have to work in pretty much every modern browser. It would be great if it works in IE6, which it will actually work in IE6, as well as 7 and 8, and all of these standard supporting browsers. Before we get too deep into writing our event code, let's have a brief review over DOM level 0 event handlers and the two different event models that we are going to have to deal with. Before we get into the cross-browser aspect, let's just look at the old DOM level 0 event handlers. And these are the property event handlers that you would actually assign through JavaScript code to the object. So we would have like document and then on mouse over equals a function of some type. And there was also on mouse out, on click. There's a variety of events that we can wire up with this type of event handler here. Now, these worked, and they worked well. They worked in every browser, and they continue to work in every browser. So they are a good fallback in case of a user is using a browser that does not support the Internet Explorer event model or the standard event model. The drawback to these types of event handlers is you can only assign one function to them. And here I have a function. It's an anonymous function being assigned to this event handler, but you can get around it by calling multiple functions within this event handler if you needed to. So if we needed to initialize some code, we can do that by calling multiple functions. Now, the problem with these is whenever you start incorporating other people's code into your web page or your application. If, let's say on click here, because that's very common. If you specify on click and you incorporate somebody else's code that uses the same event handler, somehow, or at least one of the pieces of code are going to break. It's either going to be your code or it's going to be the third-party code. Because once you assign a new function to a particular event handler, it forgets all about the previous function. So if I wanted to break this code, I could just do something like this, equals a function, and I can alert a message that says, I broke your code. So this is a problem. And when Microsoft was working on IE5, they saw this as a problem and they gave us a new event API. Instead of setting event handlers with these DOM level 0 event handlers, they gave us two methods. One is called attach event, and this allows us to set up an event handler for a particular event. In this case, I'm going to specify on click, and we do have to use the on prefix. That's important because, as we see with the standard event model, we're not going to do that. And then we just simply specify a function. And I'm going to write a function foo, and it's going to alert a message. And so we would pass the function as the second argument. Now, we could also pass an anonymous function, but if we wanted to remove this event handler, we would actually have to have a reference to the same function that we passed to attach event. So if we wanted to remove this, we would call the detach event method, specify the same event name as well as the same function. So what this code does is it sets up an event handler, so if we were to click anywhere on the document, we would get an alert message that said hi, and then this code would remove that event handler. So anytime we clicked anywhere, we wouldn't get any type of alert message. Now, if we were really fast and we clicked the button in between these two calls, then of course we would get that alert message, but that requires superhuman abilities, and we don't have to worry about that here. Now, I'm going to comment this code out. And let's look at the standard event model. After IE5 was released, we saw the DOM Level 2 specification, and it had DOM Level 2 events. And it had the same type of idea, except that it incorporated the old Netscape 4 event model and the Internet Explorer event model and kind of combined it. So instead of attach event and detach event, we had two methods. One was called add event listener, and instead of on click, we just specify the name of the event, click. Then we pass a function, and then we pass a Boolean value to determine if we use event capturing, which was used in Netscape 4, or event bubbling, which was used in Internet Explorer. True is saying that we want to use capturing. False is we want to use bubbling. Since Internet Explorer does not support capturing, then for the most part you typically see false being passed here. Now, if we wanted to remove this event handler, we call a method called remove event listener and specify that. And all of these parameters have to match what we pass to add event listener, even the function. We could have a function foo2 that had the same body, but it is a completely different function. It's a different function object. So if we were to call this line of code here, set up this event handler, then we would see this alert message whenever we clicked. And if we tried to remove this event handler using the foo2 function, it would not work. Even though these two functions do the same thing, they are two different function objects. So we have to specify the exact same parameters for both add event listener and attach event. Unfortunately, this isn't the extent of the differences between the two event models, and I'm going to refer to these event models as Legacy IE, which is IE 6, 7, and 8, and then the standard DOM event model, which is supported by Chrome, Safari, Firefox, Opera, and IE 9. Actually, IE 9 supports both. In IE 9 mode, you can use either the Legacy IE event model or the standard event model. But if you switch to IE 8 mode or IE 7 mode, then the only option you have is the Legacy IE event model. So we have more differences between just the identifiers of these methods. There are event objects that contain information regarding the event that just took place, and they are pretty much completely different between the two event models and almost incompatible. They provide the same information, but the property names are different. In the standard event model, an event object is passed to the function that is handling an event. So in this case, when we click anywhere on the document, this foo function is going to execute, and the browser is going to pass an event object to it. I'm just going to call it E. Now, if we wanted to get the HTML element that received the event, we would use the target property. And there's also another property called related target. And this is really only valid for mouse events, specifically the mouse over and mouse out event. In the case of mouse over events, the related target property is going to get the HTML element that the mouse pointer just exited. In the case of a mouse out event, then related target is the HTML element that the mouse pointer entered. There's also a type property, and the Internet Explorer event model has this type property, so we don't really have to worry about that too much, but it gets the type of event that took place. There's also a few methods. One is prevent default, and this cancels the event if it is able to be canceled. There's also another method called stop propagation, and this stops the propagation of the bubbling or the capturing. There are many other members of the standard event object, but we're going to keep things simple and just go with what we have covered here. Now, let's look at the Internet Explorer event model. like the standard event model, it does pass an event object to the function handling the event, but it only does so if you use attach event. If you were going to use a a DOM level 0 event handler, it would not pass that event object to the function. But there is a global object. And since it's global, it is a property of window, and it's just simply called event. Many times you will see window.event or just event to refer to the Internet Explorer event object. So we're just going to go with event. And let's say that we want to get the HTML element that received the event. In the standard event model, we used the target property. In the case of Internet Explorer, we use a property called source element. It's the same information, it just has a different name. And let's say that we wanted to get the equivalent of the standard related target property. Well, we have two properties within the Internet Explorer event model. One is toElement, and the other is fromElement. And as their names imply, toElement is the element that the mouse pointer is going into, and the fromElement is where the mouse pointer just left. Now, if we wanted to cancel an event, then in the standard event model, we use the prevent default method. Well, we don't have a method, but we do have a property called return value. And we could just set that as false, and that will cancel the event. We can also stop the propagation, and the only type of propagation in the legacy IE event model is bubbling. So we would actually use the cancel bubble property, set that to true, and then we have canceled or stopped the propagation. So let's use all of this information and let's write some cross-browser code to handle events for all of the major browsers. The first thing we want to do is decide upon the API to set and remove event handlers. Obviously, we want some instance methods for XObject objects to do that. But it would also be nice if we had the ability to set event handlers without creating one of these objects. So we are going to provide a couple of static methods to do that. We need a way to add an event handler and remove an event handler. So let's just call these functions add event. We'll set that to a function. We need the object to set an event handler on. We need the event type, and then we need the function to execute. And let's go ahead and copy this code, and let's add one to remove an event. Now we need to decide how we are going to write our cross-browser code. Some libraries invent their own API. They may base it on one that already exists, but there are some slight differences. Other libraries emulate other types of APIs. We are going to go the emulation route. That allows us to write more code now so that we can write less code later. And in fact, if we emulate the standard event API, then we can write standard code inside of our event handlers and not have to do any type of code branching as far as using the properties on an event object. This will actually make it better in the long run, because once legacy IE is gone, which of course is going to be many years down the road, but once it's gone, then we don't have to change any of our event handling code because it's all going to be standard code. So since we are going to emulate the standard event model, we don't really need to do anything special for browsers that support the standard event model. So we are going to use feature detection here. And if type of add event listener is not undefined, then we are just simply going to call add event listener, pass the event type, pass the function, and then we're going to pass false to use bubbling. Once again, this is cross-browser code. Legacy IE does not support event capturing, it only supports event bubbling. So in the interest of cross-browser code, we are going to go with event bubbling. And now we need to do some feature detection for Internet Explorer. So if, let's say, attach event, because that's what we are going to use. So if type of attach event does not equal undefined, then we are going to use attach event. So object attach event, and we will pass in on EVT for on click or on mouse over or whatever, and then pass the function. And then last, as our fallback, we want to use the DOM level 0. So we are just going to do object on plus EVT equals function. Now we are going to go over emulation here in a bit, but let's talk about this code here. Every time we call this add event method, we have to make at least one decision. If it's a standard-based browser, then it's going to make this decision. It's going to return true, so we're going to use this code. But if it's not a standard-based browser, then it has to make another decision, and that is determining if attach event is implemented within the browser, and if it is, then use it. So as it is right now, this isn't very efficient because every time we call, we are adding time to the execution of this method call. But the decision isn't the only thing. We are also performing some identifier lookups here. And that can also add more time to the execution of our method. So we can actually speed things up if we perform this check one time and when the browser is loading this code. And then if we specify feature-specific versions of add event and remove event, then we can speed up the execution of those methods. So let's go ahead and let's speed things up here. So let's actually make our feature-specific versions of add event. And let's go ahead and get rid of this. We'll get rid of this. And let's do the same thing here. And lastly here. Now this is more code, obviously, but it pays off in the long run. Even if we call add event 2 times, we've automatically made our code execute faster. So, or we've saved time. So here we have feature-specific versions. So if it's a standard-based browser, this is all that the add event method is going to do, is set an event listener. If it's IE, all it's going to do is call attach event. Although we are going to add some code in here to emulate, or at least to emulate part of the event model. And then, of course, if it's a browser that is not supporting either of these event models, then it uses a DOM level 0 event handler. Okay, so let's talk about emulation. Emulation is actually easy. All you have to do is identify the goal that you want to achieve and then do your best to achieve that goal. As far as the standard event model is concerned, our goal is to send an object that contains the standard event object properties to the event handler so that we can use those inside of our event handler. Well, in order to do that, we can create a function, which I'm going to call handler. And this is actually going to be the function that is going to be called when this particular event fires. And it is going to call the function that we passed to add event. So let's go ahead and call that there. And let's put handler here. So inside of handler, we are going to create our own event object and then pass it to this function here. Now we went over the type property, the target related target. We also looked at the prevent default and stop propagation methods. So let's emulate those properties. We are going to create a variable called type, and we are going to set it as event type. And then we want a related target. and we are going to give it a default value as null. Now in the standard event model, related target is only valid for mouse over and mouse out events. So if some other type of event took place, then related target is going to be null, and so this is a nice way that we can set a default value for that. But if it is an on mouse over or a mouse over or mouse out event, then we want to set the appropriate information for it. So let's see if the type is mouse over or if it's mouse out. And then we will set the value of related target. Now in the case of a mouse over event, related target is supposed to have the element that the mouse pointer left. So let's do if type is mouse over, then we want to specify event.from element because that is the element that the mouse or the mouse pointer just left. And if it's not a mouse over event, if it's a mouse out event, then related target is going to be the element that the mouse pointer is moving to or just entered. So that is going to be the to element property. So now we have related target and it has the appropriate information that we need. So all we have to do now is pass our own object to our function here. So the first property is going to be target, and this is going to be event.sourceElement. We also need the type property, which is going to be type. And let's, well, we need related target. And that's going to be related target. And let's add a property to reference the Internet Explorer event object. Now, inside of our function here, we could still access that global event object, but it would also be nice if we just had a reference to it within our own event object. So let's say that this is underscore event, and we are just going to give it a value of the current event object. And then we want two methods. We want the prevent default method and the stop propagation method. So prevent default, that's going to be a function. And let's use the underscore event property. This is prevent default, so we want to use the return value property and set it as false. And then we want to emulate the stop propagation method. We will use the underscore event property again, and then we will use cancel bubble, and we will set that as true. So now when this particular event fires, then this handler function is going to execute. We are going to create our own event object and then pass it to the function that we actually want to execute when an event occurs. Now we're actually not done with this method. We are going to come back and make a few more changes here, but in order to do that we need to understand why, and to get to that point we need to create the feature specific versions of remove event. So let's go up to our standards code. We'll copy and paste, and we'll change add event to remove event, and then we will change this call to remove event listener. That's an easy change. This one will be easy as well. We'll just need to change this to remove event and then set this as null. Now, whenever we assign an event handler and then we want to remove that event handler, we have to pass the same exact function object that we pass to attach event. There's no other way around it. And since we are using a private function inside of add event, we cannot access this function outside of add event. So we need to come up with some way to access this particular function, and a good way to do that is to just add it to our DOM object. But we also need to have some type of name for this particular function. It's going to be an actual member on this object, so it has to have a somewhat unique name. So we are going to create a hash value. And I'm going to use e underscore as a prefix, and then we are going to use the name of the event and then the function. Now, there's no guarantee that this is going to be unique, but it should be sufficient for our needs. Next, we want to get rid of handler here, and we just want to use object and then pass in the fn hash. And this will create a member on our DOM object, and it will assign this function to this member. So then we can just copy this, paste it here, and we have a globally accessible function. And we really have to know the name of this function in order to access it. So let's write the remove event version of this. Remove event equals a function, object, evt, and function. Now, the two pieces of information that we are using with this hash is the event type and the function, which we are getting here. And then we just have to make sure that that is an actual function, because we don't want to attempt to remove this event handler if this function does not exist. So let's do type of, and then we will do object fn hash. If this is not undefined, then it's pretty safe to say that this is the function that we are looking for. So we will call detach event. We will specify on evt and then object with our hash value. And whenever we get here, we don't want to have this particular member again. We have already used it to detach an event, so we are going to delete it from this object. And so with that, we have successfully emulated the standard event model, or at least part of it. Now, of course, we would actually want to implement every property that we can. For the purposes of this exercise, we're just keeping it simple, otherwise it would take a lot of time to do that. So now that we have all of our cross-browser code written, let's see what it would be like in order to use it. So since this is a static method, we can just use xObject and then add event. Let's pass document, and let's do click as well, and we want to pass a function. Let's first use an anonymous function. There, let's just use e here. And now we have an event handler, and it's getting past this event object, and since we are emulating the standard event model for Internet Explorer, then all we have to do is use standard space code. So let's say that we wanted to ensure that whatever element that we clicked on had a class name of foo. And then if that's the case, then we want to change its color to, or its text color to red. So we could do e.target.className. If it equals foo, then we want to change its color to red. Now, of course, we would actually want to cache eTarget since we are using it multiple times, or we could just use target e.target and get rid of this here. And so we are using standard space code, and it's working in all of our browsers. If I were going to run this, which I guess we could do that, let's add this to our page here. Let's start up a browser. And what did I name this? xObject. Okay, so we have our page here, and of course we are getting everything. If I click here, then we should not see anything because we don't have a element with a class name of foo. So let's do this, class foo, and we'll say hello world. So if we go back here, we will see our text. If we click it, then we can see that the color changed to red. Now I am in IE9 mode. So let's change this to IE8. And if you just wanted to test to make sure if we are in fact in IE8 mode without the standard event model, then we can just do type of add event listener, and we can see that it is undefined. So we are using the legacy IE event model. I'll refresh the page, click here, and our color is red. So now we have an event API, at least an API that anybody can use without creating one of these objects to set and remove event handlers, and it is going to work across all the major browsers, and we can write standard space code inside of our event handlers. Oh, there's actually one other thing that we need to do. If we were to look at the this variable inside of this event handler and run it in Internet Explorer, we will see that this refers to the window object. And that's because even though we have attached an event to the document object, the event handlers get executed within the context of window. If we open this up in a standard space browser, we will see that it actually executes within the context of the object that we have attached the event handler to. So we need to emulate that as well. And that's really easy. All we have to do is use the call method, pass the DOM object as the first argument here, and then the second argument is our event object. So now if we run this in Internet Explorer, we will see HTML document. So now we have an even better implementation of our emulation for the standard event model within Internet Explorer, and that also completes all of our static methods for events. So we can use these methods in our instance methods. So let's write those now. We are going to put those on the prototype, and we are also going to call those the same things, add event. And we just need the event and the function to execute, because we already have the DOM object that we need to pass here with the L property. So we will simply just call the static method xObject, add event. We will pass in this L and then the event and the function. And we will follow the same pattern for remove event. So let's change this to remove event, and we will call the remove event static method. Let's also add some comments so that we can at least see this a little better. We'll put event instance methods, and then down here we will say event static methods. Let's also return this in these methods. This will allow us to chain these methods if we want to. So we could create an object. Let's just do that right quick. Object, we don't really care here. We just want to call add event, and then we could call remove event if we wanted to. So we can chain methods together if we return this, as we have done here. Now, it would be nice too if we had a shorter version of setting up events, because it's just entirely too much typing to specify the event here. So let's create a few more methods here on the prototype. So prototype, and these are going to be shorthand. They are actually going to be named the name of events. So this is going to be click. It's going to accept a function as a parameter, and then we are going to call xObject, and then add event, this L, We'll specify click and then pass the function. Now we can actually do something a little bit different with these shorthand. With the add event and remove event, the event handlers are going to be executed within the context of the element object. Wouldn't it be nice if we had a way to set event handlers that would execute within the context of our particular object? And we can do that with these shorthand methods. So let's create a variable called that. We will assign it this. And then we are going to add this event handler, but instead of passing function here, we are going to wrap it within another function, and it is going to call our function within the context of that, and then we will pass the event object to it. So now if we were going to set up a click event with this click method, then the event handler will execute within the context of our object here, and we can use the properties and methods within the event handler for this object. Now we want to make this method chainable, so let's return this as well. And then we can also replicate this for other events. So let's copy this a couple of times, and let's set mouse out and mouse over. We also need to change the events here. Now we can actually do this a better way to cut down on our code. We could create an array with the names of these event handlers. Mouse out and mouse over, and then we could iterate over this array and create methods on the prototype with these names, and also specify these events here. But we are going to take the lazy way and just copy and paste. Now before we test this code, there's something I want to address within the constructor function. I haven't been entirely pleased with this test here, testing with inner HTML. While this will work because all of the modern browsers do support inner HTML, we can make this completely foolproof by making sure that what we have is an actual element. And to do that, instead of using inner HTML, we are going to use the node type property. So we'll do node type, and we want to make sure that it is not undefined, because even Internet Explorer 6 implements this property here. This tells us that we at least have some type of object from the DOM, and then we can compare node type. So object node type, and we want to make sure that it's 1, because elements have a node type of 1. So if our code passes this test here, then we can be very sure that this is an element, and we can assign this object to our L property. Something else that we can do is get rid of some more code by caching this operation here into this type variable, and let's just replace this code here. Now before we test, we need to get rid of our previous test, so let's get rid of that code at the bottom, and let's go to our HTML page. So for this test, we're going to add another script element, and we are going to create an X object called foo, and we are going to call X object, pass in foo. Now we don't have an element with this ID, so let's go ahead and add this ID to this div element here, and then we will use the foo object call click and pass a function to it. Now since we are using click, we are supposed to be able to use this, and this will reference this foo object here. So we'll do this, and let's use the underscored CSS property, and let's set the text color to red. Let's also set the background color. I can't type. And let's run this in Internet Explorer. So let's refresh the page. And if we click here, then we can see that we are getting a text color of red. The background color is yellow. I believe this is still in IE8 mode, so let's make sure. Yes, IE8. Let's check in Chrome, and we get the same results. So click is working, and it's really safe to assume that mouse out and mouse over are working as well, since we just copied and pasted those and just changed the method names and the events. So it's pretty safe to assume that those work. And that pretty much sums up how we can provide an event API for our library, and one that we can use by creating an XObject object, or just by using the static methods if we don't want to create one of those objects. Now, one thing of note, we used this underscore CSS property, and this is quote-unquote private. In the next part of this series, we are going to look at a style API, so that we don't have to use these within our code. We can use our style API. We'll also look at how we can add some Ajax functionality as well. So that puts a plug in the jug for this part of the series, and I will see you next time.